This is the second video covering section 2.4, where we're going to still continue to solve linear equations. And we're going to do it two ways. We're going to clear fractions to do it. We're going to do it just using regular algebra. So if we look at this problem, 2/3 x equals x plus 3. I think what I can do is I can convert this x here into 3/3, right? I can rewrite this into thirds. Okay, so let me do that. So this would look like, I'm going to rewrite everything, right? So I have 2/3 x. That's going to be equal to, so instead of writing x, I'm going to write 3x over 3, right? 3x over 3 is the same as 1x, right? Plus 3. So now if I subtract 3x over 3 from both sides, you see that I'm left with 2/3 x minus 3/3x, and that's going to be equal to 3. So minus 3/3x plus 2/3 x is going to leave me with negative x over 3, right? Or think of this as negative 1x over 3 equals 3. And to finish the problem, if I multiply both sides by negative 3, right, the negatives cancel and the 3's cancel, right? Negative times negative is positive. So I'm left with x equals negative 9. Okay? So that's one way to handle this problem, right? I just rewrote this x into thirds because my denominator was a 3, right? So I ended up with having 2/3 x minus 3/3 x, leaving me with negative 1/3 x, okay? And when we cleaned everything up, we left with x equals negative 9. Okay, so if you did not like what I just did, I'm going to solve the same problem using a different technique. So you might want to pause the video for a second and then just try to do what we've just done, and then we'll solve the same problem using a second method. Okay, so let's try the next method. I'm going to use the method where we find the LCD, right, the least common denominator, LCD, and then I'm going to multiply each term by that LCD. So think of this as x over 1, 3 over 1. So my denominators are 3, 1, and 1. So the least common denominator is 3, right? 3 is the smallest number that each of these denominators will divide into evenly, right? 3 divided by 1 is 3, 3 divided by 3 is 1, right? So if I multiply each term by 3 over 1, right? Because remember, 3 over 1 is the same as 3, right? Whoops, made a boo-boo there. Right, so this is 2/3 x. All right, so I multiplied this first term by 3 over 1. I'm going to multiply this second term by 3 over 1. All right, so 3 over 1 times x. And then the last term, I'm going to multiply by 3 over 1 as well. All right, so this is 3 over 1 times 3 over 1. All right, so I've multiplied all three terms by my LCD, which is 3 or 3 over 1. So let's cancel where we can, right? 3 over 3 cancels, and I'm left with just 2x. So I'm going to rewrite that all the way over here, 2x. Remember, the goal here is to get rid of all our fractions. All right, so now I have 3 times x divided by 1. Whoops. That's equal to 3x. And then 3 times 3 over 1 is 9. And now, if I subtract 3x from both sides, I end up with negative x equals 9. And if I divide everything by negative 1, I'm left with x equals negative 9. Okay? All right, so again, this technique is called clearing the fractions, because once we multiplied by our LCD, we were left with an equation that did not have any fractions, right? And that's the whole point, right? So we're going to continue to now solve a few more of these problems by clearing the fraction, right? And on the next page, they give us a little definition here, right? It says to solve an equation with fractions by clearing denominators. multiply every term on both sides of the equation by the least common denominator, right, the LCD. All right, so again, I want to get to a few practice problems. These are some examples where they show you how they're clearing the fraction, but I want to get to a practice problem. Here we go. So on page, looks like 94, we have some practice exercises. So let's start, I'm going to start on the left side with this problem 1. So I'm going to clear this out, and we'll do problems 1, maybe problem 3, and in the next video we'll do a couple more. So I took the liberty of rewriting number 1 over here. And see, at first I was going to multiply each term by 7, but then I realized the first thing I should do is really just add the 9 to both sides. So 2 over 7x equals negative 17 plus 9, which equals negative 8. Oops, my pen went away. Right, negative 8. And to finish the problem, I'm going to multiply both sides by the reciprocal of the fraction. Right, because you see quickly the 7's cancel, the 2's cancel. And I'm left with x equals negative 8 times 7 divided by 2. So I can reduce the 8 and the 2, right? Because 8 divided by 2 is 4. And then negative 4 times 7 is negative 28. Okay. So that's number 1 done for you. Let's try number 3. All right, so I'm going to erase all of this stuff and do number 3 in this area. So again, if you want to pause the video for a second before we work this out, that's fine. Okay, so for number 3, I rewrote it up here, right? 1 over 8x minus 2/3 equals 1 over 12. I could look and I see, all right, what's my LCD here? I'm thinking my LCD is going to be, I'm thinking 24, right? 24 is the smallest number that 8, 3, and 12 will go into evenly. So if I multiply each piece or each term by 24, we have 24, think of it as 24 over 1, and then 24 over 1, right? We're going to multiply each of these, 24 over 1. So the 24 over 8 becomes 3, so I'm left with 3x, right? Because 24 divided by 8 is 3. Minus this 24 divided by 3 becomes 8 times 2, right? Right? 24 over 3 is 8. 8 times 2 is 16. And then 24 over 12 is 2. So when I finish the problem, I add 6 to both sides. I'm sorry, 16. And I'm left with 3x equals 18. Divide everything by 3. And you get x equals 6. Okay, that wasn't so bad. I'm going to stop here, but definitely keep practicing these practice problems. The answers are on the back of your book. Thank you for watching.